Hey folks, Sebastian from Madrigal here. Today we're going to talk about a system that makes it easier to create level geometry. So the program that you're seeing is the Basis level editor. It's a self-made level editor for the Basis game engine that I'm using to create the Project Slide game. So up to this point, the levels that I've been working with have been essentially a set of terrains and some number of meshes placed on top of that terrain. So for example, this square that you see here, this plane, is a terrain. You can edit that terrain directly in the editor if you want to. And then if you want to place a tree on top of it, you select a tree model here and then you place it in the level like this. And this is fine. However, it's not very flexible because you still only have a finite number of meshes here to select from. And if you want to create a new one, you have to go into something like Blender or some other 3D modeling program and create the model. You have to export it to a file and then somehow bring that into the Basis game engine. And if you're working with a level, especially in the early phases of level creation, you typically want to create lots of so-called white box objects. So essentially what it means is that you'll want to create lots of geometry, playtest it, iterate on it. Usually you want to throw away a lot of stuff that somehow didn't work. And it gets kind of slow if you have to bounce back and forth between different programs and export to files. You have to keep remembering which files you actually want to keep around and which ones are stuff that you iterated on but didn't find work that well, etc., etc. So that's not that great. And lately I've been working on a new level for the game, and I kind of figured what would be the best way to solve this problem. And previously I've come up with a system that I call the primitive geometry objects, and these three are primitive geometry objects. So here we have a cylinder, for example. They can be boxes, spheres, or cylinders, and you can just set the sizes of them directly in the editor. And using a combination of these objects, I've been able to create some of the white box geometry needed directly in the editor without having to create lots and lots of meshes and exporting them and importing them and etc., etc. So that has gotten me sort of halfway there, but it's not a very good system because you can't create like arbitrary geometry. You can only create these three shapes and then combine them into more interesting shapes. And so I've been doing some research on how other engines do it, and if we look at Unity, for example, Unity has this system called ProBuilder. So here you can create a ProBuilder object, and you can immediately start modeling it. So do things like this. This is very nice, and this allows you to without leaving the I keep messing around with the camera here. Without leaving the level editor, you can create all kinds of shapes and iterate on them very quickly. So, like I mentioned, one thing that this solves is you don't have to mess around with any files. If you create this object and you figure that it's not actually what you want, you just delete the object. You don't have to go and delete any files along with the object. So the data is stored directly in the level file. And of course, another thing is that you can model directly in the scene, in the context of other objects. So if you have something right next to this object, you can immediately see how it fits into the whole scene. And so this would be sort of like the ideal system. If I could have this, that would be great. But I realized that actually creating a system like this, where you can just create arbitrary geometry. This is creating a full 3D modeler. So that's maybe not something that I wanna put my time into. So I started thinking, okay, what is the next best thing we can have if we can't have a ProBuilder inside the Blender, the basis level editor? What is the next best thing we can have? And I already create essentially all my 3D models in Blender. So I figured, how can I leverage that and sort of try to make the best out of the situation in this case. So let's look at Blender. So if we compare this to the ProBuilder thing that we just looked at, you have many of the same features here. Like you can do probably everything that you can do in ProBuilder and more, I assume, in Blender. And definitely it is something that's going to be of higher quality than anything I could produce. So the problem is that if we use Blender, then we still have to bounce back and forth between the programs, and we have to export and import files and do the whole dance. So if we can't get rid of Blender and the two programs, how can we make that interaction as frictionless as possible? And the system that I came up with is called BlenderSync, and it's found right here. It's an add-on that I've created for Blender, and I'll show you how it works. So let's put these right next to each other on the same screen. So in an actual work scenario, I would probably keep these on different screens, but for this video, I'll keep them like this. It's a bit crammed, but I hope we can manage. So we start the BlenderSync server. So you can see that the chain is connected, and what that means is essentially if you have multiple Blender instances running, maybe you're looking at the mesh for this tree, for example, in one, or doing some texturing or whatever you're doing in Blender, then that's fine. You can have multiple instances of Blender open, but the one that has the BlenderSync server running is the one that is sort of dedicated to this sort of level geometry creation, and you shouldn't open any other files in this, or they might get overwritten in this particular instance. So now if we want to create an object here in the middle of these objects, for example, we create something called a quick mesh, and this is kind of the equivalent of the Blender, the ProBuilder object. So the quick mesh has a button here, edit in Blender, and when we click it, the Blender interface reacts accordingly, gets rid of everything else, and creates a BlenderSync target object for us. So now we can just start creating this. Let's make this a house, for example. And you can see here that there's this icon has appeared here. It means that we're currently editing an object, and we can finish the editing, we can update and keep editing, or we can cancel the edit. So for now, let's just finish editing, and let's see what happens in the basis editor when we do that. So we click here, and boom, we have our weird looking house thingy show up in basis. And since we finished the edit, this Blender instance goes back to an empty scene. So we have some weird UV distortion here on this side, so let's just fix that. Edit in Blender. Let's do a quick smart UV project. Okay. And we click update and keep editing. And so it sends the data back to basis. The UV distortion is fixed, but we can still keep editing this guy. So if we want to, we can do something like this. Haven't exactly thought this through, but just something to show you that it actually does work. Finish editing. There we go. And so there are a few things to note here. First of all, like the iteration is very quick. You don't have to play around with any files or anything like that. And now if we save this level here in basis like this, the data is now stored here. You can just shut this down, open up a new Blender instance if you want, and when you click Edit in Blender, it will get the same mesh back here. So no messing around with files. Everything is done automatically for you. Another very cool thing here is that we can have it create a triangle mesh on the physics side. So if we do like a debug, put a debug sphere here in the scene and move it up and then simulate, you can see that it actually has collisions already for it. So very handy for prototyping things. Okay, so we've solved a few of these problems that we set out to solve. We couldn't get rid of the multiple programs, jumping between two programs, but we made it very sort of quick and easy to bring data over from one to the other. But now we have the problem of knowing where the other items are in the environment. Like, what if you want to actually make it so that this face here lines up with this face on this side? And there is a feature here. If you click this Include Surroundings checkbox, you can see that it shows a sphere. And this is the radius of like how much do you actually want to include as sort of guidelines or guiding objects or surrounding objects here on the Blender side. First of all, let's just cancel this edit that we have going on, and then we can add a few more objects to the scene. So let's add a cliff here, for example. And these white box cliffs are these are essentially the kind of object that I would like to actually create completely using the BlenderSync system in the future. We shouldn't need these kinds of game objects anymore. I'll just put a car here for good measure to show you that we can actually include very complex geometry as well. And yes, cars don't actually have wheels in the editor currently. That's why it looks kind of silly, because the wheels are actually brought in by a runtime system. Okay, so now we have to determine how much of the surroundings do we want to include. So maybe something like this. We can sort of just see the rock faces, but we're not bringing in the whole cliff. So yeah, let's edit in Blender, and here we go. So here you can see the geometry that we brought in roughly matches this sphere. I say roughly because what is actually brought in is determined with an axis aligned bounding box, but I just chose to visualize this with the sphere. So any triangle that touches that axis aligned bounding box is brought in. And if this looks a bit confusing, you can turn on the random colorization here, and we can see that Blender has added two objects for us. We have the BlenderSync surroundings object, and we have the BlenderSync target. And these are the names that you're not supposed to actually change these, because this is how it identifies the objects. And no matter how much surrounding data you actually bring from Basis over to Blender, that data won't get sent back to Basis. Only this target object data gets sent back. But now, of course, if we go back to what we what we talked about earlier. You can select these faces like this, and you can just extrude them exactly to that vertex, if I can actually manage it here, like so. And of course we can update it in the scene, and we can keep iterating on it like this. So now we're actually getting kind of close to the ProBuilder experience, in the sense that you can just take one of these and sort of match it exactly to the surroundings. And of course you can just hide this surrounding object if it's annoying. Yeah. Finish editing, and we can see that it actually matches exactly. So this is pretty much the gist of the new system. Let's go have a look at a slightly more realistic example. So we go to our prototype level, and this is a level that is actually part of the game. And I figured, just as an example, maybe we'll want to create like a garage building here for one of these guys. So let's create one more. Actually, let's put a layer here, and we'll call this layer demo garage, and we'll just auto load it. And that just means that it gets loaded automatically when the game runs, without us having to actually do anything. And we'll move the object to the active layer like this. And this guy is actually scripted, has some script here, so let's just remove that so it doesn't try to do anything crazy. Okay, so now then, let's create a quick mesh. And in this case, maybe we'll actually, let's move the car. So let's say that place is roughly, let's move it a little down. When the car is inside the garage, it will be in roughly that spot. So that means that we'll want to actually rotate this object slightly, so that it roughly matches the vehicle. And maybe we can move it a bit down as well. And we'll definitely want to include the surroundings, because this is a case where we want to keep the size of the vehicle and everything in mind when modeling this. That should be enough, but maybe let's make it 25. And let's perhaps duplicate one of these scale mannequins and bring them closer, so that we have like the human size as a scale guide as well, something like that. So now that the guy is well and good inside the surroundings. And we still have the server running, as can be seen from this icon here, server running. So we just click edit in Blender, and depending on how much of the surroundings you actually include, exporting them can take a while, which you can see. But of course you don't need to do that all the time. You can just you can do it whenever you need to. And again, let's turn on the random colors. So okay, a few things to note here. First of all, this object now has a rotation. This rotation matches up with the rotation of the object in the scene. So the idea here is that the actual mesh data for this object is not supposed to have any rotations baked in. So it tries to sort of maintain the transform of the object in the scene. And because of that, we'll want to go into local mode, because that way we can scale it along the X, for example, like this, and then along the Y to make it a bit wider, and maybe a bit more, and then make it taller, something like that. Maybe a bit more still, so that it intersects with the ground. And let's create a few edge loops, scale them by Y, like this, and another one this way. And now we can temporarily hide the background, get rid of the faces. Oh, not that. And create some of the walls here and the inner ceiling. And let's see what we have. So this looks a little, these walls look a little thick, I would say. So let's scale them a bit more, like this, and then this roof doesn't need to be this ridiculously thick. Oh. Yeah, I haven't really thought this through, sort of to the extent of how I want to actually model this thing, but let's just do it sort of by eye. Something like this, and maybe we'll want to add like a door here. So how tall is that guy? Something like this, and then one more in this direction. Yeah, that looks about right, and then we'll cut a hole here. Like so. And now of course you can just update and keep editing, and you can see the result here. Ooh. See the result here in the editor, and like I said, in this case, when we're working with something that has actually quite a lot of background stuff included in the Blender environment, and makes sense to just make these incremental improvements so that you don't have to export the surroundings all the time. So let's fix that UV distortion again, like this, and maybe we can, I don't know, maybe we can put in a small chimney or something here. Not that it really makes sense for a garage to have a chimney, perhaps, but so it's minus 14.9 is the rotation. So let's rotate Z minus 14.9, and we get the alignment or the rotation set up correctly, like this, and then boom. Right. So here's the house. It does look a little weird now that the ground is kind of uneven. So let's do something about that. We can record a height for the ground here, and then just sort of flatten it out a little bit. And this is actually this is one thing that's very nice about this new system, is that you can sort of jump back and forth between the two programs very quickly. Now that we actually modified the surroundings here, now if you just click Edit in Blender again, it does have to export the surrounding objects again, but it means that we'll get the updated ground here in Blender. And if we actually hide that, you can clearly see like the change that it did. And with that in mind, maybe we can lower this just slightly, like that. And yeah, I think that's a pretty good white box garage. So let's finish the edit. We save the level here on the basis side, and we make the physics type be trimesh. And now if we can just play the game, see how it works. So I'm gonna select a vehicle that's a bit closer to the place we modified, and there's our house. And we should have collisions, which we do, yeah. And of course we can select this guy and play around with this to make sure that the house is sort of big enough to hold one of these guys. We should be able to, if we fire like a grenade at it, it should bounce off, which it does. So cool. That's pretty much it. I'm sure you can see the potential in this system, especially compared to having to build an object like this with just boxes, spheres, and cylinders, and also compared to having to go back and forth between modeling programs and the level editor. It's not quite ProBuilder in the sense that we still have to jump between the two programs, but there are actually some benefits to this as well. So one benefit obviously is that building this system takes a lot less time than actually building something like ProBuilder. I managed to get this system done in about a week, and that included learning how to build these kinds of Blender add-ons from scratch. I had never done that before. And another very interesting thing is that if you edit this in Blender now, like this, there's nothing to stop you from actually hijacking this object to sort of act as a base for something that you want to actually build completely in normal Blender, so to speak. So now that we have this object here, you can just stop the server, and this way, like the basis editor won't be able to actually take this away from you anymore, so to speak. You can delete the surroundings if you don't need that, and then just maybe reset this rotation. And now, of course, you can just save it as a normal Blender file, and that way you can use this as a beginning for like a high definition version of this house, which you can then just put in the exact same space and place in the editor. So that's very nice. And and of course one benefit to this, like I already mentioned, is the fact that we have the very powerful Blender modeler here. So at this point I could just have a very quick tech breakdown, like how does this system actually work. And a shout out to the Blender developers for making it very easy to create these kinds of add-ons. Like for example, here you have this start server button, and if you look at the pop-up, like I can't move the mouse off the button now, but if you look at the pop-up, you can actually see the Python command needed to or used to run that start server command. So it's bpy.ops.object.start BlenderSync server, and this is the same thing for everything in the UI, or at least everything made with Python. So if you want to add a cube, you see the Python bpy ops wm tool set by ID, and then some parameters there. It's very, very nice. And if you want to add, let's say, a circle, it's bpy ops mesh primitive circle add. So you can copy these. You can just go like, okay, I want that command added to my script, and you can just copy it directly from these pop-ups. So very, very easy, and it means that you don't have to go reading through the documentation all the time to figure out how to do something. But yes, like I mentioned, I had never done any kind of Blender add-on development before this, and I managed to get this done pretty quickly. Essentially, the add-on consists of 2 Python files and a very simple small DLL file, which I'll get to in a bit. So this init.py here, I'll make that a little larger for you. It essentially just kicks off it's the entry point for the add-on. Essentially, it lists some objects that need to be registered, things like that, and it does load this one DLL file, which I'll get to in a bit. And then we have the actual BlenderSync Python script, which contains essentially all the logic on the Blender side needed for the actual exchange of mesh data, etc. And this is about 576 lines long, including a lot of commented out things, because this file was kind of like a place for me to test out things, seeing how they work, and it just organically developed into this sort of main add-on file. So it's not perhaps very well organized, but I think it's pretty easy to read. So here, for example, I think this is the most complex function in the whole file, and it's the one that sends the mesh data to basis. It's pretty easy to see what it does. Like, if we're not in object mode, then go into object mode, figure out the target object and the surroundings object. If we don't have a target object, then error out. If we have a surroundings object, then record whether or not it was hidden, and then unhide all the objects. Do all kinds of small validation of the data. And here's an interesting thing. We deselect everything, we select the target object and invert the selection. So essentially we select everything except the target object, and then we delete it. So this is the place that strips away all that surroundings data. We don't have to worry about accidentally including it in the mesh file or anything. Only the target object is included. And then what we actually do is we save the file as a temporary, or not a temporary, but we save it as a blend file with only the target object in it, and then export it to an FBX file, which in turn is then passed on to the basis mesh converter, which converts it into a runtime format. So essentially goes through the same path of bringing meshes into basis as I would normally do. Like if I had this file here, I would export this to an FBX file, and then my mesh converter would actually figure out that, okay, this file was changed on disk, and then reconvert it. Instead of that, this script just does it by itself, and then it removes some of those temporary files. The way we actually communicate with the basis editor, as you have probably figured out already, is over the network. So we have a server here which needs to be running for this whole system to work. And the network library that I'm using, called eNet, which I'm using for essentially, well, everything in this game engine, I decided to just wrap it inside a very simple DLL file. So that is the DLL which gets loaded here by the add-on in the very beginning. So BlenderSync lib DLL. You can actually use eNet from Python through a wrapper, but I had some trouble getting that to work, so I actually just wrapped it here inside essentially a one file DLL. And here you can see these extern C functions. So is server running, get target object rotation, get target mesh file path. the file that are sort of decorated with this can be called from Python just straight away. And here's also a function for sending the updated mesh file paths. So once we've saved the blend file and the FBX and the converted basis bin mesh file, we write them to temporary files, and then we send those to the basis editor. And this is the call that you can see right here. So send updated mesh file paths. And once we've done that, we're essentially done. We can, if we keep editing, we open the mesh that we just saved to make sure that we're actually seeing the exact same environment that we would if we just clicked edit in Blender again. And if we have the surroundings file, then we import it again on top of that. Otherwise, we just clear the scene and we're done. And this is like by far the most complex thing. So it's not a very complex add-on, but yeah, Blender makes it very easy to create these kinds of things. So that's pretty much it. If you have any questions about the technical side of things, then by all means let me know in the comments, and I'll try to answer anything, any questions you may have. But yeah, that's the BlenderSync system. Really happy with how this turned out. I was kind of worried that creating Blender add-ons would be complex, or that there would be something that I hadn't really thought of. But actually this worked really well. I'm hoping to be able to show you some of those new levels that I spoke of very soon, once I have them in a shape where I can actually feel confident enough to show them. And I also have another quite technical video about occlusion culling coming sooner or later for those that might be interested in that. But if you made it this far, I thank you very much for your time. If you have any questions or comments or feedback or anything, let me know. Remember to click all the buttons and bells and give likes and so on. And I'll see you in the next video. Bye.